Okay, so got a little camera stand, so hopefully that will improve the video quality a little bit. Following on from my Mill CNC testing, this is a little design that I've done on Fusion 360 for a little stepper motor plate. Now had a dry run at drilling the slot for the stepper motor pulley hole. I did a sort of a scratch pass on top of the plate with the machine just to see that it behaves properly. Everything worked fine, but I had I think it was 23,000 lines of code, I was actually using a very light cut rate, so lots of code as a result. And then I was also a little worried that the feed rate was a bit high, so I've had a go at modifying all of that. So basically I've selected a 12mm aluminium or alu power flat end mill, limited my spindle speed to 1000 rpm. That's kind of where it's geared up at the moment. I need to address that and get a higher spindle speed rate at a later date. Cutting feed rate is 200 millimeters per minute. Yeah, so I've basically defined the workspace. I use the chain selection. I'm still learning, so basically I defined the area that the tool has to cut, and then the little arrow indicates whether it has to cut on the inside of that or outside of that. And then the heights, I left it as standard. I just added the bottom one, which is the bottom piece. My vise is clear of the hole, and the slot's going to go right through the piece. It's a 12mm piece, so I think that will work. Tolerance, okay, it's about the accuracy of the actual finish or the actual path it takes. I'm not too worried about that. Optimum load I'm busy playing with to look at what's the depth of cut and adaptive clearing, although I believe the system automatically adjusts depending on whether it's cutting and the blades working on the load of the blades. If it's cutting two sides at the same time, it will back off apparently. I'm not so sure how that works. Slot clearing, I think that's basically to start a sort of a little pocket in the middle, and then instead of just plunging and helix spiraling up right to the edges of the slot, it basically creates a little hole, a little slot in the middle, and then uses long passes to do the finish. Yeah, so I've limited that to 15mm. I've got a 12mm end mill, so that will allow it to helix a little bit up to 15, and then I want to see how it finishes off with the long linear moves along the sides. I haven't tried that yet, so, and I'm going for conventional just to play it safe. I think it's a safer way to cut, especially when you're still learning how to cut like me, how this whole system works. So yeah, basically that's how I've set it up. You can have a look on the actual simulation. So because I don't have my Z-axis, although my motors, stepper motor is running, my Z-axis is obviously not done because this is the plate to secure the motor to the Z-axis. But I'm going to manually plunge it to the bottom, and then I'm going to use a dwell function just to give me the time to manually plunge to the bottom, and then hopefully the cuts that you're seeing now are going to be done. There's no Z-axis function there, so I don't expect anything to go wrong. And then I've set it up to just stop on the retract, so it doesn't try and go home, so it doesn't accidentally bump into the rest of the workpiece, because I don't have an automated Z-axis yet. So yeah, we'll come back just now and set the system up, and then let's see what happens.